Okay, these are the equations we're going to be using to solve problems for free fall and projectile motion too, which is really just free fall. First, I'm going to put our constant up at the top. So what I know is I know that the acceleration due to gravity, which is what we actually call g, because remember sometimes we give constants their own variable. So lowercase g is 9.8 meters per second per second. I'm putting that at the top because we're going to be using that number over and over and over again if we have something that's dealing with free fall. All right, first problem, what is the instantaneous speed? So speed also means velocity because we're traveling in one direction. What's the instantaneous speed of an egg that drops out of a tree and has been free falling for 0.98 seconds? So let's write down what we want, or what we know. What are our givens first? They're asking for instantaneous speed, so that's what I'm going to be solving for. Instantaneous speed or velocity. I'm putting V for velocity since that's what shows up in each of these equations. We're given time. Time is 0.98 seconds. And we know G, because it's free falling. Oops, so it's 9.8 meters per second per second. So now I have to find an equation that helps me solve for V, instantaneous velocity or speed, and includes those two, and that's going to be this one right here. So instantaneous velocity is equal to G times T. Plug in my givens. That's what I'm solving for. G is 9.8 meters per second times T is 0.98 seconds. If I look at my units, I've got 1 second on the top and a second on the bottom, so one of my seconds is going to cancel out, which means that my answer is going to be in meters per second. That's what I'm left with, which makes sense because I'm solving for velocity. Now let's look at the numbers. We've got 9.8 times 0.98, and that gives me 9.6 meters per second. Next question, how far? So they're asking for distance. How far has the egg traveled after it has been falling for 2.6 seconds? So I also have time, and I always have G, oops, because it's falling. So which equation am I going to use that includes those three? And that's going to be this one up here. So distance is equal to 1/2 GT squared. Don't forget that the time is squared. Now let's plug in my givens. T squared, 2.6 seconds squared. Now if I look at my units, my seconds are also going to be squared. So if I have seconds squared, that means I have 2 seconds on the top, 2 seconds on the bottom. So both of those are going to cancel out, which means my answer is going to be in meters, which again makes sense because I'm solving for distance and distance is measured in meters. So I'll plug in my numbers, oops. So 1/2 is 0.5 times 9.8 times, oops, hold on, let me start over. I'm going to do the squared first, especially since I have a real simple calculator here. So I'm going to do 2.6 times 2.6, then times 9.8, then times 0.5. And that gives me 33.1 meters. Next one, someone drops a penny off the top of a tall building. How long does it take to travel the whole way down if the building is 300 meters tall? Okay, so I have a distance. It's going to be 300 meters. How long does it take? I'm solving for time. And we always know G because it's a constant. So I'm going to be using this same equation. Plug in what I have, so 300 meters equals 1/2, 9.8 meters per second, times T squared. This time it's not already set up for what I want to solve for, so I'm going to have to do some algebra. So right now I've got T squared with other things, so I'm going to divide both sides by what is multiplied by to get rid of that on that side. So divide, you could do this step all at once. 1/2 times 9.8, do that first. But I'm just going to divide it all at once like this. Okay, so all of that cancels. Here my meters are going to cancel because I've got meters on the top, meters on the bottom. So 1/2 9.8 is 4.9. So I'm going to do 300 divided by 4.9, which gives me 61.2 equals t squared. We still have t squared. Oh, and this is going to be seconds squared because we had 2 seconds over here. So if I take a square root of both sides, square root of that gives me 7.8 seconds for the time. Oops, didn't circle that one up there. What's the instantaneous speed after the penny has been falling for 4 seconds? So I'm solving for that instantaneous speed or velocity. Time is 4 seconds. We always know g if it's free fall, which means I'm going to use this equation, v equals gt. So plug in what we have, plug in the givens. Then do my math. 9.8 times 4 gives me 39.2. 1 second is going to cancel out, so my answer is going to be in meters per second, which is good, makes sense, because I'm solving for velocity, and velocity is measured in meters per second.